Problem 11. Container with most water. Hey everyone, this is Keystrokes. Welcome back to the channel. I'm a senior software engineer in one of the MAANG FAANG companies, and I love to bring these educational videos where I share my industry experience and help out others be a good developer. Today's topic is to solve LeetCode's problem 11, which is container with most water, which is a pretty straightforward problem, but grasping the idea of the solution can be slightly tricky, and that's why this problem is tagged as medium difficulty. So let's take a look at the problem statement. We are given an array of integers of length n, and each element of the array represents a vertical height, and these heights represent lines, let's say on the 2D plane. So let's say if the first element of the array is 1, then this is how you can visualize the line. And here you can see for the second element, which is 8, the height spans from 0 to 8. Now our goal with this problem is to find two such vertical lines such that the two lines and the x-axis together, they make a container, and the container will hold water. Now we need to find two such lines such that we get a container that can hold the most water for the given input. So here we can see, for example 1, this is the height array, which is 1, 8, 6 and so on, and we can see the heights are 1, 8 and 6. That's how they represent it. And in this case the answer is height 8 and height 7 as the two vertical lines combined with the x-axis, which can hold 49 units of water. And this is the output that we need to return, that is how much water the container can hold. Here's another example. There are only two values here, 1 and 1, and because we need a pair, this is the only solution. And in this case, the maximum water this container can hold is 1. And we can determine how much water the container can hold by multiplying the distance between the two pairs and the minimum of the two heights of our pair. Otherwise, the water will start to spill from the shorter side. Okay, so let's take a look at the things that we need to know before we can solve this problem. So you should be familiar with loops. And as for data structures, all you need to know is arrays. So let's get into brainstorming and try to solve this problem. And if you're liking the video so far, then please don't forget to like and subscribe, as I'll make more videos covering interview topics and so many other topics that will just help you become a better developer. Also, you can show me your support by buying me some coffee by using the link in the screen, which is also in the description. Well, let's get right into it now. Okay, so let's start with a very simple example, which was actually example 2 in the LeetCode question. So we are given the heights array, which is 1 and 1. And if we want to represent this on the 2D plane, we can represent it as 1 and 1 height right here. And also, let me add the indices of these array elements, which will be 0 and 1 right here. Now, because there are only two elements in this array and we just need to find the pair, our answer becomes 1 and 1. So in this case, the container can hold 1 unit of water. And that's because it's height times width, which in this case is 1, which is either of these heights times the width, which is 1 minus 0, which is the right pointer, and the 0th pointer, which is 1 times 1, and it becomes 1. Now let's take a different example. What if our input array was 1, 2, 3, and 4? Now in this case, if we draw our 2D visualization for this, this will become 1, this becomes 2, this becomes 3, and this becomes 4. So placing the first element with height 1 at index 0, second element with height 2 at index 1, then at second index we have element with height 3, and then at height 4 we have the third element. Now let's see how we can solve this. So we need a pair of heights here. So in this case, maybe we can assign a pointer over here and another pointer over here, which is 0 and 3. Now, if we try to fill this container with water with the 0th and the 3rd index as the two lines, then we fill up this whole area, which will be the right pointer minus the left pointer indices, which gives us the width of the container. And then we have the height of the container in this case, which is the minimum of the two lines, which will be min of 1 or 4, which becomes 1. And in this case, the width was 3. So the answer becomes 3 times 1, which is width times the height, which is 3 units. Now in this case, what can we do? We can either move the left pointer forward or the right pointer backwards. If we move the right pointer backwards, then we'll be working on index 2, which has a height of 3. And if you realize, in this case, the width of the container shrinks as well. Now it becomes 2, but the height of the container that can actually hold the water remains the same, and it still stays at 1. So if we keep moving towards the left, we are actually reducing the size of our container. And this can actually just get worse. Hypothetically, let's say if there was a line here, which was 0.5, then your container height became even smaller, and then you're holding even less water. So maybe it makes more sense to move the left pointer towards right. So let me clean this up a little. So the max we have seen so far was 3, and our point is pointed to the 0th element and the 3rd element. So this time if we move our left pointer forward, that is move the left pointer to 1, now what happens? Our height now becomes minimum of 3 or 2, which will be 2, and then our width becomes 3 minus 1, which becomes 2 again, and then the area that this covers becomes 2 times 2, which is 4, and then this 4 becomes our new max. And this actually makes sense, because we want to keep our tallest height that we had as constant and move our shorter side to the other elements just in case we find something that's taller than the current height, which was this case, where initially the height was 1 and then it became 2 right here. The container's width did shrink as well. It went from 3 to 2, but overall it helped us find a larger area. So now taking a look at the example that we had in LeetCode, we had 9 array elements here. The first element is at height 1, the second is at height 8, the next one at 6, then at 2, and then at 5, then 4, and 8 again, then it's 3 and 7. And let's mark the indices of our array, which is 0, 1, 2, 3, 4, 5, 6, 7, and 8. So doing what we did before, we assign the left pointer to the 0th element and the right pointer to the last element. Now our width in this case becomes 8 minus 0, which is 8, and our height becomes minimum of the 1 or the 7, which gives us 1, and so the area becomes 1 times 8, which is 8. So the max we have seen so far is 8. Now keeping this 7 constant, because we like to keep the taller side of the container, and then moving our left pointer towards right, so that hopefully we can increase the height of the left side of the container, we end up at 8. Now with 8 here, our width shortens by 1, so now it becomes 8 minus 1, which gives us 7, and our height becomes the minimum of the left pointer, which is 8, or the right pointer, which is 7, and in this case it's 7, and our area becomes 7 times 7, which is 49. So our new max now is 49. So continuing on now, we keep the longer side of a container, which will be 8 in this case. So we move our right pointer towards left. So now right pointer points at 7, which points to the line with a height of 3. So now our width becomes 7 minus 1, which is 6, and our height becomes min of 3 or 8, which is 3. So our area becomes 3 times 6, which is 18. 3 times 6, which is 18. Now 18 is smaller than 49, so we don't update our max. Now between 3 and 8, 8 is still the taller side of the container, so we keep it as it is. And so we move our right pointer towards left again, so now it points at the 6th index, which is a height of 8. So now our width becomes 6 minus 1, which is 5, and our height becomes min of 8, 8. So our height becomes 8. In this case, the area is 8 times 5, which is 40, which is still smaller than our max. So we don't update our max anymore. And it seems like 8 is the tallest number for the rest of the iterations. So the right pointer just keeps moving towards left until it hits the 2nd index right here. And after iterating on the 2nd index, it goes towards the 1st index. And now because left and the right pointer point to the same index, which is 1, we stop our iteration because the width of a container effectively is 0 now. And doing any more iterations beyond that will just be a repetition. So our answer becomes 49, which we found by using number 7 and number 8 as the height of the container. And that's the answer. Okay, so I hope the brainstorming made sense. And here we have the pseudocode of the solution that we just discussed. So we have the input array, which is called height. Then we assign 2 pointers, the left pointer and the right pointer. Left pointer will be assigned to 0, and the right pointer will be assigned to the last element in the array. And then we assign max capacity as 0. Now, while the left pointer is smaller than right pointer, we run this loop. Now, the first thing we determine is the height of the container, which will be the minimum of the left and the right pointers that we have. And we choose minimum because you can only hold water up to the minimum height of the two sides of the container. Then we determine the width of the container, which is pretty straightforward. It's just the distance between the right pointer and the left pointer. And then the capacity of the container becomes the height of the container times the width of the container that we just determined. And then we reassign the max capacity to be max of the max capacity that we had before and the new capacity that we just calculated. And now in the next step here, we have to determine which height we should change. So if the height of the left pointer is greater than the right pointer, then we should move the right pointer towards left by decrementing it. And the idea here is to change the minimum of the two heights we have in case we can encounter another height which is further taller, which can help us hold more water. And after the loop is done, we just return the max capacity that we have been tracking right here. Okay, enough with the pseudocode. Now let's code it out. Okay, so here I have IntelliJ, and we have two classes, main and solution, like usual, and I've created the function that we see in LeetCode for this problem. Also, in the main class, I've put in two test cases that were used as an example in LeetCode. Right now, our solution just returns 0, so if you run this program, both of our test cases should fail. And as expected, they say it's wrong answer. So now let's implement a solution that we just discussed. So we'll start by assigning two pointers. One is called left pointer and we'll assign it to 0. Then we'll create a right pointer, which will start from the last index of the array, which is done by height.length minus 1. And then we'll declare another variable to track what's the maximum capacity that we have seen so far. And we'll return this max variable as part of the output. Now running a loop until the left pointer does not meet up with the right pointer. And then we'll figure out the height of our container, which will be int current height, which should be math.max. And then we take the values pointed by these pointers. So height, left pointer, and height of the right pointer. And let me minimize that. Okay. And next we figure out what's the current area, which will be the height multiplied by the width. And the width of the container will be right pointer minus left pointer. And then we update our max to take max of the current max or this new current area that we have determined. And then we move our pointers. So if the height pointed by the left pointer is greater than the height pointed by the right pointer, then we should move our right pointer towards left so that we can try and find something which is longer than the right pointer. Otherwise, we move our left pointer forward with the same reasoning. And I think that should be it. Let's try to run this program on our test cases and see if it succeeds. Well, looks like this didn't work, so we have a small bug in our program, and I think I just spotted that it's in the current height. We don't want the max of the current height, rather we want the min of the two heights of the container, otherwise the water will spill from the smaller side. Let's try it again, and let's compile this. Okay, this time it says we have gotten our correct answer. So let's copy this to LeetCode and see if it works there. So copying this and going to LeetCode and replacing the existing function with what we just wrote, and let's run the base cases. The base case was successful, and now let's submit this and see if LeetCode likes this solution. Okay, this looks pretty good. That's all I had for this video. I hope now you understand how to solve this problem, and you can quickly apply the ideas we learned through this problem in any other problems that you face. Well, if this video helped you, don't forget to like and subscribe, and to follow me on Twitter and show me your support by buying me some coffee. And I also have so many other platforms where you can find me, like Patreon, Insta, Facebook, and even TikTok. You can find those links in the bio link, which you see on your screen and in the description. Well, I'm working on more videos and they'll be coming out soon. Thank you so much for joining in today.